Hello everyone, this is Mohit Gowda bearing the USN 1V21 CS 101. Today we are going to learn about computer graphics and image processing. So, in computer graphics and image processing, let's learn about 2D geometric transformations. In this presentation, we'll explore the fundamental of 2D geometric transformations used in computer graphics, including translation, rotation, scaling, reflection, and shear. These transformations from the building blocks for manipulating and animating 2D objects and scenes. So now let's first take a look at translation. First, the initial position. The object starts at an initial position, as you can see in the image. Then, second, shift vector. A shift vector is applied to move the object to a new location. The final position. The object ends up at the new translated position. The process of moving an object to a new location by applying a shift vector. This is useful for positioning objects in a 2D scene. So now about rotation. So rotation. First, the initial orientation. The object starts at an initial orientation. Second, the rotation angle. The object is rotated by a specific angle around a fixed point. Third, the final orientation. The object ends up at the new rotated orientation after the rotating angle. The rotation transforms an object by spinning it around a fixed pivot point. This is useful for creating animations, simulating motion, and adjusting the orientation of 2D elements. So now about scaling. Uniform scaling. The object is scaled by the same factor in both the x and y dimensions, preserving the aspect ratio. Non-uniform scaling. The object is scaled by different factors in the x and y dimensions, distorting the aspect ratio. Resizing. Scaling can be used to resize 2D elements to fit different layouts or display sizes. The scaling transforms an object by making it larger or smaller. This is essential for adjusting the size of 2D elements to create the desired visual composition. So now about reflection. First, the flip horizontally. The object is reflected across a vertical axis, creating a mirrored image. Second, flip vertically. The object is reflected across a horizontal axis, creating an upside down image. Third, diagonal reflection. The object is reflected across a diagonal axis, creating a mirror image on a slant. The reflection transforms an object by flipping it across a specified axis, creating a mirrored version of the version of the original. This can be used to create symmetrical designs or simulate reflections in water or mirrors. So now about shear. The initial shape. The object starts with a regular rectangular shape. Second, shear vector. A shear vector is applied, distorting the shape of the object. Then the final shape. The object ends up with a skewed parallelogram like shape in it. Shear transforms an object by skewing or distorting the shape along a specified axis. This can be used to create the illusion of 3D perspective or to adjust the alignment of 2D elements. The last, composite transformations. Combining transformations. Multiple 2D transformations can be combined to create complex effects, such as scaling, rotating, and sharing an object. Transformation order. The order in which transformations are applied can affect the final result, so the sequence must be carefully considered. Powerful possibilities. Composite transformations unlock a wide range of creative possibilities for manipulating and animating 2D elements in computer graphics. By combining multiple 2D transformations, designers and developers can create highly complex and dynamic 2D scenes and animations. So now, let's take a look at the applications in computer graphics. First, the user interfaces. Transformations are used to position, scale, and rotate UI elements for responsive and adaptive designs. Second, animation. Transformations are essential for creating 2D animations from simple movements to complex simulations. For example, the GIF. Third, game development. Transformations are used to manipulate and animate 2D game assets and objects. Last, the graphic design. Transformations are used to create and modify 2D illustrations, logos, and visual effects. 2D geometric transformations have a wide range of applications in computer graphics, for user interfaces and animations to game developments and graphic designs. So that's it about 2D geometric transformations. Please like, share, and subscribe. Thank you.